thermometer is a device used to measure temperature. Its name is derived from the Greek words thermo, meaning heat, and meter, meaning measuring device. The variability in types of thermometers and their uses continues to increase as technology advances. Thermometers are used in meteorology, medicine, and everyday applications like setting your thermostat. Today, we will focus on the digital thermometer, often found in hospitals, medical centers, and households. But before the digital thermometer came to be, a basic thermoscope design was used. So how did the thermometer come to be? In 1592, Galileo Galilei developed the first type of crude thermometer, which consisted of a clear liquid and masses of varying weight. In 1611, Sanctorius Sanctorius added the thermoscope to this previous design. Following this, Grand Duke Ferdinand II of Tuscany developed a seal to eliminate barometric influence. But what exactly does the thermometer consist of? The answer is, it depends. There is such a wide variability of thermometers in our everyday lives. At its core, a thermometer contains several key components. Typically, it contains a power source, a resistor, a microchip that serves as a voltmeter, which records the voltage change and displays it as a change in temperature to the person using the thermometer, an ammeter that records the current change, and lastly, one of the most important components is the thermistor, which can be considered a transducer because it creates a change in electrical properties due to a physical change in heat. This is the most sensitive temperature detector available. There are two types of thermistors: negative temperature coefficient and positive temperature coefficient. We will focus on the negative temperature coefficient, or NTC, because this type of thermistor provides quick and accurate responses, which is essential for its application in medicine. There are multiple components of a thermistor. The negative temperature coefficient of silver sulfide was first discovered in 1834 by Michael Faraday. In 1930, scientist Samuel Rubin found a copper oxide also had a negative temperature coefficient of performance and successfully applied it in temperature compensating circuits of aviation instruments. With the development of transistor technology, significant progress in the study of thermistor has been obtained, and in 1960, the NTC thermistor was first developed. It can be found in a myriad of devices responsible for controlling temperature, measuring temperature, and temperature compensation. So how exactly does a thermistor work? A thermistor opposes the flow of current by having a high resistance. As the thermistor warms up, meaning electricity is flowing through the device, resistance drops and lets the current flow more easily. When temperature rises, the base voltage will increase, and the transistor receives power and turns on. They do not work well with excessively hot or cold temperatures, due to the fact that it's ideal for precise temperatures. This is why they are best for uses in medical fields, food heating, car temperature regulation, because these temperatures don't have to deal with either ends of the temperature spectrum. This material has allowed us to create devices that allow us to precisely control the temperature of things such as our food, our vehicles, and to monitor our internal temperature, something that would not have been possible prior to 1930. The economic impacts of this material are enormous, due to the fact that we can obtain a precise and exact temperature when needed, instead of spending thousands of dollars on over or underheating a material. It is made of metal oxides, which is a very good conductor, and leads to the efficiency of the device. Semiconductors are used for lower temperatures, such as germanium. Silicone thermistors are used at temperatures up to 250 Kelvin. Therefore, this device can span a wide range of temperatures. The physics behind thermistors is constantly growing and advancing, especially in the automotive industry. The next time you're sick, or the next time you're microwaving your food, hopefully you'll appreciate the science behind our everyday lives.